So we're going over these 4 factoring problems today. So we're going to approach number 1 first. And we always start with the same thing. Whenever we factor, we always check for the GCF first. So here for the numbers, I know that 12 and 4 have a common factor of a 4. Then I have to check the variables, and they do have factors of x, so I'm able to pull away 1x from both of them. So if I divide both terms by that GCF, I can figure out what's left in parentheses. 12x squared divided by 4x is 3x, and negative 4x divided by 4x is a minus 1. In number 2, we always check for the GCF first. There just wasn't one. So now we notice that there's 3 terms, and our leading coefficient is equal to 1. So we can simply ask ourselves, what numbers would multiply to 10, but would add to negative 7? So I know that if I chose negative 2 and negative 5, that would multiply to a positive 10, but negative 2 plus negative 5 would add to a negative 7. So those are my numbers. And since the leading coefficient was just a 1, I know that both of those would start with an x. So now approaching number 3, we always check for a GCF. And in this case, there is not a GCF. So we notice that there are, again, 3 terms, but in this situation, our a value, or our leading coefficient, is not a 1. It's a 3. So what we know here is that we're going to factor it into 2 sets of parentheses. But we can't just start with an x, because if we just start with an x in both parentheses, then all we're going to get is x squared. And that number has to be 3x squared. So the only ways I could multiply to get a 3 are a 1 and a 3. Now whatever numbers finish out these factors, I know that at the end, in our last step, they're going to need to multiply to be a 2. So it somehow has to be a combination of a 1 and a 2. Now the idea is I don't know where exactly to put the 1 and the 2. I have to guess and check. So maybe the 1 goes there and the 2 goes there, or maybe the 2 goes here and the 1 goes there. We're going to guess and check until we find our combination that could somehow be a negative 1. So if we check the first one, 1x times 3x is our 3x squared. 1x times 2 would be 2x's. 3x times 1 would be 3x's, and at the end, 1 times 2 would be 2. So this is the 1, because we can get this group of 2x's and 3x's to be a negative 1 if the x's in front, or if the 3x's were negative. So the group that made 3x's should be negative, and that came from this stage right here, so I know that my 1 should be negative. So my final answer, I don't need to check this option because I already found it. So my final answer is x minus 1 times 3x plus 2. As we approach number 4, we always check for the GCF first. There is not a GCF of all the terms. We see that there's 4 terms, which means we should use factor by grouping. So we group the first 2 terms together and look for their GCF. So x cubed and x have an x in common. So if I divide both of those by x, I'd be left with x squared plus 1. Then we look at the next group, negative 3x and negative 3x squared and negative 3 have a negative 3 in common. So if I divided both of theirs by negative 3, I would get x squared plus 1. And at this point, we're doing a quick check-in to make sure that this parenthesis here is the same as that parenthesis there. And it is, so we know that that makes our common factor. So the common polynomial is x squared plus 1. And then the other terms, so the GCFs of each group, make up our second factor. So this would be our final answer.